Generally, when we're talking about confidence intervals, there's some critical value we're looking for to determine whether or not we reached our goal. Now, in the case of data where we have one mean or median or proportion as our target value, we want to know whether that target value is inside the confidence interval or not. So, for example, if we're measuring weight loss and our goal is that our clients will have an average of 15 pounds of weight loss by the end of the intervention, that 15 pounds is the critical value. And when we get the confidence interval, we want to know if 15 pounds is inside that confidence interval. So in this first case, if 15 pounds is here on the left part of the number line and it's outside of the confidence interval, that means that the average number of pounds lost was greater than our target value. Here in the middle, you can see that our critical value is inside the confidence interval. So maybe our confidence interval stretches from 12 to 20. In that case, we can't rule out the possibility that we did not reach our goal with 95% probability. Now, here's the worst case scenario for us. Let's say our goal is 15 and the confidence interval only stretches from 5 to 10. In that case, we definitely know we did not reach our goal of 15 on average. Now, sometimes if we have before and after data, or if we've got two groups of participants, we may be subtracting the means. So the average of one group minus the average of the other group. And in that case, 0 becomes our critical value. So what we want to see is 0 being outside the confidence interval. If 0 is inside the confidence interval, we can't rule out the possibility that there is no difference between the two groups with 95% probability. And when we're talking about odds ratios, our critical value becomes 1. So an odds ratio of 1 means that there's no difference in likelihood between the two conditions. So if 1 is inside of our confidence interval, that means we can't rule out the possibility that there's no effect. If the confidence interval for the odds ratio is greater than 1, so the lowest value extends from say 2 to 4, that means that we know whatever our intervention is increases the likelihood by at least 2 and possibly as much as 4 times. If our confidence interval is entirely below 1, so maybe it's from 0.25 to 0.75, then we know that the intervention makes the outcome we're interested in 25 to 75% less likely than it otherwise would be. So a more concrete example, this is from the one of the matching exercises in class. And when you're doing a hypothesis testing, in this case, we're looking to exceed this proportion of 65%. So if our proportion that we observe is 70% and our p-value is less than 0.02, that means that we're at least 95% sure that we've exceeded our goal. In this case, even though 75% of our clients wound up employed, the fact that our confidence interval, that our p-value is greater than 0.05 means that there's not a statistically significant difference between our observation and 65%. So we can't say with 95% certainty that we exceeded our goal. here if is a situation where the observed proportion was 80% and our confidence interval is 70 to 90%. So what this is telling us is that in the subjects that we saw or in the clients that we treated, we got 80% employment. And based on our observations, we're 95% sure that if we did this a bunch of times, 95% of the time, the outcome would be between 70 and 90% of employment. And here, our observation was 70% of clients employed, but the confidence interval was 60% to 80%, which means we can't rule out with 95% certainty that the actual number of clients we would find employed if we did this with an infinite number of clients would be closer to 60%.